Security posture can't be treated as a quarterly checklist anymore. In this topic, we'll design proactive agents that continuously watch cloud, identity, and endpoints, detect misconfigurations and drift, reason about attack paths, and trigger remediation before exposure becomes an incident. So far, we've moved from core agentic concepts into secure architectures, then applied those ideas to SOC triage and incident response. Now we extend that foundation into continuous posture management, where agents help identify weaknesses earlier and reduce risk before incidents form. Traditional security often begins after something has already gone wrong: an alert, a compromise, or visible impact. Continuous posture management moves the work earlier. Agents monitor configurations, privileges, endpoints, SaaS, cloud, and network controls for risky drift. Then they rank findings by threat likelihood, business impact, and operational effort, helping teams reduce the most important exposure before it becomes an incident. A proactive defense agent is more than another dashboard. It sits between security telemetry and operational systems, combining cloud posture, identity, endpoint, asset, and vulnerability context. From there, it correlates signals, ranks risk, and recommends the safest next step. The critical design choice is guardrails, scope limits, approvals, logging, rollback, and human oversight. That separation allows the agent to move from read-only insight to recommendations to controlled action without bypassing change management. Agents need more than alerts. They need context they can trust. The posture context layer turns scattered telemetry into a shared understanding of assets, identities, owners, criticality, configurations, vulnerabilities, and exceptions. First, data is normalized across clouds, endpoints, SaaS, and directories. Then it is enriched with business meaning, such as environment, data sensitivity, and service tier. Finally, it is compared against baselines and approved exceptions, so agents can suppress noise, prioritize real risk, and recommend actions that fit the business. Misconfiguration and drift agents work like continuous posture auditors. They compare the current environment against approved baselines, security policies, and reference architectures. In cloud, they catch public buckets or open security groups. In identity, they surface privilege paths, stale accounts, and missing MFA. On endpoints, they flag disabled EDR, outdated agents, or weak admin controls. The key is classification. Approved change should pass. Accidental drift should be corrected, and suspicious modification should trigger urgent investigation. A posture agent becomes useful when it turns noise into decisions. It should weigh exploitability against business impact, then enrich that score with asset criticality, internet exposure, identity privilege, threat intelligence, and existing controls. That context can change priorities. A medium vulnerability on a crown jewel system may outrank a critical issue on an isolated test host. Strong agents also group related findings into remediation campaigns, reducing alert fatigue and helping teams fix material risks. Safe remediation is a loop, not a one-way automation path. The agent detects a posture issue, assesses business and security impact, and recommends a specific fix with rationale. If the change is risky, approval and a change record come first. Execution stays limited to authorized actions. Afterward, the agent validates the result with independent checks, not just success messages. Finally, it documents evidence, decisions, and rollback steps, so the next cycle starts from a trusted record. In enterprise environments, a recommendation is not enough. It has to become governed work. The agent packages the change with impact analysis, affected assets, risk, approvals, and a rollback plan, then sends it into ServiceNow, Jira, or Azure DevOps. Policy decides whether remediation is only recommended, scheduled, or executed automatically. Ownership mapping routes the request to the right team, and validation confirms the environment actually improved after the change. The goal is not to automate everything. It is to match autonomy to remediation risk. At level 0, the agent only observes and reports. At level 1, it recommends a fix with evidence. At level 2, it prepares a change request for approval. At level 3, it can act, but only for low-risk, reversible changes with validation and rollback. As autonomy increases, guardrails must become stronger around confidence, blast radius, and business impact. A proactive defense agent can turn scattered architecture evidence into a usable threat model. It reads assets, identity policies, network paths, and trust boundaries, then connects them to likely attack techniques using frameworks like MITRE ATT&CK CK or STRIDE. The value is prioritization: which attacker objectives matter, which abuse cases are plausible, and which controls reduce risk. Still, the model is only a starting point. Humans must validate assumptions, business logic, and accepted risk. Attack path analysis asks a practical question. If an attacker gains one foothold, what chain could carry them to critical data or production systems? Agents explore privilege graphs, identity links, network reachability, and cloud permissions to find those chains. The value is context. One weak control may seem low priority on its own, but when combined with role chaining, nested groups, or service accounts, it can become part of a critical path. Effective fixes break the path, not just isolated symptoms. Once an agent finds a risk, the next step is more than reporting it. The agent should propose controls that interrupt the specific attack path. For an over-permissioned cloud workload, that might mean least privilege, MFA, segmentation, stronger logging, patching, or EDR policy changes. Each recommendation needs expected risk reduction, operational impact, and a clear owner. Then validation proves the control works, business functions still work, and residual risk is measurably lower over time. Posture reporting works best when it fits the audience. Engineers need actionable proof, affected assets, evidence, commands, policy references, and validation results. Leaders need a broader view: risk trends, business exposure, remediation progress, and the decisions required. Dashboards connect both worlds through shared metrics like critical exposures, MTTR, drift, and control coverage. Agent-generated reports should still be reviewed, so accuracy, tone, and enterprise risk language stay consistent. Agentic defense becomes most valuable when it moves upstream, continuously detecting drift, prioritizing real attack paths, remediating safely, and proving outcomes. Keep humans, change controls, validation, rollback, and audit trails in the loop. Next, we'll examine governance, compliance, adversarial risk, and strategic operation at scale.